Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama-Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Jesus. And you can get a hold of us in Bakersfield at the number 636-4357, or if you're in San Luis, you can call toll-free at 1-866-636-6284. You can also email us at dothemath@kern.org or watch us online at dothemath.net. Also look for us on social media, Facebook, Instagram, Twitter, and YouTube.
All right. You know what? Today is the final live broadcast for 2017. So today, because I know this gets rerun every once in a while, but Wednesday, December 6th is the final live broadcast day for 2017. We will be back live with tutoring once again in the new year 2018. Anyway, Jesus, nice to have you on board again today.
Thank you.
And while you're here, I'd like everybody just kind of stay updated as to what your regular position is, other than coming in to help us once in a while.
Sure. When I am not doing the math with you all, I am working at Cal State Bakersfield. I'm part of the faculty of the teacher education department. And so my role is to teach upcoming teachers the math and science methods courses over there. So getting them ready for the future and helping to get ready for teaching in the classroom.
So you're still doing the math.
I'm doing the math.
You're just not doing the math on
Not
the math.
online, and not on TV.
Well, you know what? We have a very special guest in studio with us this afternoon. We'll be heading out to COM to check out about the holiday lights at COM. And speaking of that, every student that phones in today, and once again, today is the final day that you can win these tickets. Holiday lights at COM. You can win yourself 2 tickets to that. Have you been out to that show?
I haven't this year. I do it all the time.
Well, it only started a couple of
family.
days ago, but it is underway, and we'll be going through, I think, until we go back to school around the 6th, 7th, or something like that.
That's great. Just warm though.
Yeah, that's right. It does get a little cool out there. But I think they have hot chocolate and coffee and things out there to help warm you up. Anyway, before we get to all of that, let's first take a look at today's Math in the News. The holiday season is upon us. All right, and I haven't seen you before Thanksgiving or since Thanksgiving. Did you have a nice time?
Did. A lot of family time. Loved it.
Now, did you have to travel, or did
Stayed home.
everybody's kind of here?
We're starting our own tradition at our house. Staying at home and making dinner and having fun.
There you go. You know what? We've had other things, but we're going to start ours. We're staying here. If you want to come over, come over. There you go. A lot of traditions. A lot of families have different holiday traditions, and one of those things is Santa Claus visiting, and Santa Claus has a little snack that kids put out sometimes for him, cookies and milk and things like that. So the question was posed, what would happen if Santa had cookies and milk at every single house Santa went to?
Oh, yeah.
So we can see Santa Claus here sampling the cookies and
And
milk
he looks
right
like
here.
he's eating some cookies.
Yeah. Well, you know, I mean, if they're there and they're free, it's like, why not? You know, you're running around, it's cold out, and why not have a snack? So, any idea what would happen if Santa had cookies and milk every night?
Yeah.
Or every house?
I would have to know how many houses he's visited, but I would imagine it's a lot.
It's going to be a lot. So what we did is I took a look, and I'll move this down here a little bit. So we're going to say that one cookie is about 100 calories. Obviously, there are some that are different, higher or lower, but we're just going to say each one is about 100 calories. A glass of milk is about 100 calories as well. So if he had 3 cookies and milk, it would be about 700 calories per house. We're going to guess about 2 billion houses would be visited on that evening. So that would be a lot of calories.
Oh, yeah.
Now, a pound is about 3,500 calories. So if you took that number of calories, divided it by the 3,500 for a pound, you would have about 400 million pounds that Santa would gain during the visit. Now, the reason I bring that up is because there is a method to do these types of problems. First, you would have somebody looking like that on the couch or the seat right there, getting a little stuffed from cookies and milk. But the factor label method, have you worked with this at all?
Yes.
So here's an example problem. If a space shuttle can travel at 17,000 miles per hour, how many meters per second? So you're taking, and just like the calories and the pounds, going from one unit to another one. So you can see that we have 17,000 miles per hour. We need to get to meters per second, so we need to convert that into metric, first of all. So we go through this whole process, and then you can see process of elimination that it's going to come out to be 7.6 times 10 to the third meters per second. And I just brought that up because factor label method is one of the methods that kids can use to solve problems like that when they're going from one unit to another.
Oh, yeah. Finding out how much a basketball player makes per second.
Right. We've done that before, and how much a baseball player would make if they're up there for, let's say, 4 pitches.
Right.
Whether they strike out, whatever the case might be. But anyway, that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 this afternoon, as well as most Tuesdays and Wednesdays throughout the regular school year. In studio with us right now, we have Calvin. How are you?
Good.
Why don't you let everybody know where you go to school and what grade you're in?
I go to Stockdale Elementary and I'm in 4th grade.
And how long have you been at Stockdale?
Since kindergarten, which is 5 years.
So you've been there 5 years now, and you're in 4th grade. What do you like best about 4th grade, other than going to school longer? Because you're in school 30 minutes more every day, and I know you like that. But other than that, what's the best thing about 4th grade so far?
I don't really know.
Do you get more recess?
I don't know.
Probably
Seems
about the
longer.
same. Seems longer, right? Well, you're there longer. Do you like the math that you're doing right now?
Yeah.
Do you like the stories, like whatever literature and stories you guys do? All right, so that's because you're having a good 4th grade year. All right, well, you know what? We're going to put you to the test today. Are you ready?
Yeah.
All right, because I know that you brought one of your pages of homework here. So we're going to take a look at this, and why don't you go on over to the board, and you and Jesus are going to explain a little bit about this for me, all right?
Okay.
Okay.
All right, head on over to the board. We'll take a look at number 1.
Okay, I'm going to write
It says,
the problem down.
find the product, and we have 16 times 19. And it looks as though you've got a model. And Jose, if you want to draw the model up there.
So I'm assuming we're going to start with something along these lines. Does this look like what you guys are doing in your class? In
Yeah.
a grade like that? Okay. Do you want to take over for me here? I can go through it with you, and you can kind of look at it, and we can actually, oops, maybe not drop it down now. So we have the number 16 times 19, and it's really difficult to look at this problem and to say what the answer is, but we can actually break this into smaller pieces. The number 16 can be broken into smaller pieces, and the number 19 can be broken into smaller pieces. And that way we can actually compute the product for this a lot easier. Have you guys been doing stuff like this already?
Yeah.
Okay, so let's think about what I would break 16 into. So 2 numbers that would make the most sense to you to break it into.
This is what I'm doing in school.
Okay, sure.
For it.
And you'll close parentheses there, yeah. And we can actually, go ahead and just draw it down here, I think is probably what we'll have to do. There you go. That was 19, so he'll make a 10 plus 9. Okay, so what I'm going to do is I'm going to borrow this, and I'm going to just copy this down so the kids that are at home watching this can see what you did. You took 16 times 19, and you turned it into the quantity 10 plus 6 times the quantity 10 plus 9. Is that true?
Yes.
Okay, so now you have these 2 quantities that you can apply to your partial products grid. So go ahead and show us what you're going to do the next step on.
Wait.
Yep, you can erase. Yeah, there you go. So there's your 10 plus 6, and then you have 10 plus 9. I like the numbers you chose because we know 10 times 10 is an easy one. That just comes right off. So go ahead and fill in the product for 10 times 10. And we know that when we use 10, we can multiply 10 by, it's just adding a 0 behind the number, right? So go ahead and finish the rest of these products for us. 10 times 9 is 90, and then we have this 10 times 6 will go here, which we know is 60. Now, do you know what your 9 times 6 is? Good job. 54. So what we have here is the products 10 times 10, 10 times 9, 10 times 6, and 9 times 6. All of these are what you're doing here where we're saying we're going to add. So we're going to find the sum of all of these values here. So what we can do is, how about if I have you erase that math off to the side, and we can use that space to do these. We'll make a list of numbers that we're going to sum. Okay? So let's start by writing the first box, which is 100. And we'll add the 90 plus the 60 and then the 54. Can you do an addition problem with 4 terms?
Yeah.
All right. So go ahead and just, so that's 0 plus 0 plus 0, which is 4. And now we'll go 0 plus 9. Good. Perfect. So then we have a 2 plus 1, because the 1 in the 100 and the 2 in the hundreds place, so it's going to be 304. So our answer to this, or the product, right, when we do multiplication problem, we're looking for the product. So the product of 16 times 19 is 304. Now that's a big number, and I wouldn't have been able to come up with that on my own, but having this method is a really nice way of coming up with this answer. So we like showing this method. Good job.
There you go, nicely done. Now, Jesus, what I'd like you to do is on the left side where you're at, I want you to put down like an A, B, C, D. So we're going to put some options up there.
Okay, so the order in which you're going through, is that what you're meaning by?
I'm going to do so totally different idea. So just all the way over to the left, like we're doing a multiple choice. So go A, B, C, D.
B,
there you go.
C, and D. So we
have. And so for A, put 300. Next one, 302.
Okay.
304. 306.
306.
So Calvin, here's something that I want you to think about. Because when you take a standardized test, if you're stuck and you see that you have the options right there, and let's say you didn't know how to multiply large numbers like that, just take the last number in each of those. So the 6 and the 9. What's 6 times 9?
54.
So you know the answer must end in a 4. So which one of those answers would be correct without even doing the whole problem?
304.
Okay, so that's a way that you can kind of reason and take a little logic through, especially if you're working on time where you need to go fast and you have large problems. Let's say that problem was 4,216 times 719. That would be a problem where it would take a little bit of time to draw a model and even just calculate it out. But if you think and you see 0, 2, 4, and 6, knowing the last number of that product is a way that you can kind of go a little quicker right there. All right,
and check
so a little
for
something
reasonableness
extra for you there.
Yeah.
All right, nicely done, boys. 636-4357 is the phone number. We do have phone tutors available until 5:30. As a reminder, today is the final day that you have an opportunity to win yourself 2 tickets to Holiday Lights at Com. So all you have to do is phone in. We do your problem. You've got yourself 2 tickets to Holiday Lights. Easy as that. Speaking of Holiday Lights, that is occurring out at Com, and right now we're going to go to Com and visit with Marylou.
We are live today at the California Living Museum Holiday Lights at Com, and I have a special guest with me, Steve Sanders. Steve, can you let everybody know what your position is?
Sure. So I'm Chief of Staff at the Kern County Superintendent of Schools, which operates the California Living Museum.
Okay, can you kind of go into more detail what exactly your position entails?
So I get to work with the COM Foundation, get to oversee COM, working with our zoo manager, Lana Fain, and Sharon Adams, who's our curator of animals. We get to make this place, happen for Kern County residents, so it's amazing.
And Steve, how long have you been doing this?
Well, I've been with the Superintendent of Schools since 1998. I've been doing this probably the last 10 years.
Okay, now what goes into the lights, the holiday lights at Com?
Sure. So the COM Foundation puts on the holiday lights. It's our major fundraiser. We probably raise $200,000 net to be able to support all the great things that are happening at COM.
Is that per year?
That is per year. So this is a major deal for us. So I like to tell people that every investment in a holiday lights ticket is an investment in COM.
So not only are the everyone's coming, that goes towards it, but there's other ways as well that you can be a sponsor, correct?
Absolutely. So you can sponsor Holiday Lights, or you can just support the zoo. We have, if anybody wants to support us, talk to me, because we have a lot of ways that can make the zoo better.
Now, when you walk around, obviously there's like these posters behind us, exhibit sponsors.
Right.
Can you kind of go more into detail on how you can be a sponsor like
Sure.
this?
So we have a sponsorship package, so people can sign up for different levels, and at a certain level, you get one of these signs in front of an exhibit, and it just helps, I think, spread the word to the community that sponsors are behind this and that it's a community effort.
And there is quite a lot of posters all around.
Yeah, definitely.
Now, Steve, this has been going for about 15 years, is that correct?
Correct. So this is our 15th year. Great anniversary, so we're excited.
Were you with it from the very beginning?
You know, I've been taking my kids out here for 25 years, so I've been with it, but officially for probably the last 10 years. There were people before me that got Holiday Lights started. One guy in particular, Stan Eschner, who saw this at the Denver Zoo and thought we could do that at Calm, and so he brought it here.
It is pretty amazing because I've been in other cities and I've seen it. And actually, I was telling Josh one year, I was in the Portland Zoo, and I was like, man, that's nothing compared to, I love ours.
So along those lines, the LA Times named us as one of the top 10 light shows in the Western U.S. last year. So even beating Disneyland, which they're both great. So,
Yes.
you know, but it's a great recognition for all the work that's been
Well,
done.
I think it's because everything is so compacted
Yeah.
and everything is lit up where you have that bigger surface, it's more spread out and it's not as
Right.
beautiful as this.
Plus, we have 3 million lights. We've gone to almost all LEDs, which are energy efficient. They pop much more than the incandescent lights. So over the years, you hear people say, wow, it just gets better and better.
Yeah, I know that every year you guys are switching out the lights, correct?
Right,
To
we move
LED.
things around. We're probably 95% LED now, so we've got most of the park, but we do new exhibits. It's amazing.
It really is. Okay, what is your favorite thing?
So this year, I've had favorites every year, but this year the peacock, which is right down this pathway, you'll see it. It changes colors, and it's something new we did this year, and people are raving about it.
Oh, I can't wait. Okay, so when we come back, we're going to be hopefully talking with Josh
Yep.
and kind of going into all dynamics, what it takes to put this together.
He's the man behind the scenes, so it's
All right.
perfect.
Okay, Steve. All right, so we are going to head back to the studio.
All right, thanks for that, Marylou. 636-4357 is the phone number. Phone tutors are here until 5:30 in San Luis Obispo County. That phone number is toll-free at 1-866-636-6284. If you phone in this afternoon, you'll automatically receive yourself ice cream courtesy of our friends at Doc Bernstein's Ice Cream Lab. We have Calvin in studio with us. As a matter of fact, we are going to feed you, my young man. Not right now, though. All right? But you'll be receiving a meal courtesy of our friends at Johnny Rocket. So we'd like to thank Lydia and her crew over there. Some delicious food and mighty tasty ice cream shakes. So if you ever have go over there and use your certificate, ask for Lydia and tell her you were on the Do the Math show and you want to taste one of those shakes. Sound good? All right, you ready to go to work? All right, back to it. So on the first problem that you did, Calvin, they had a model drawn for you. So now you're going to draw the model simply with the problem that we have on here for the next one. So for number 5, it says 23 times 25. So now, Calvin, explain to Jesus how you like to go about solving this.
What is your, okay, go ahead. So what is your first step that you're going to do?
20 plus 3
Okay, so you're going to break the number 23 into two numbers.
times 20
Yeah, the quantity, perfect.
plus 5.
Nice. Okay, so we have these two products right here that we're going to multiply. 20 plus 3 is going to be multiplied by 20 times 5. The way you broke it up, I like that because now we have numbers that we can multiply pretty quickly in our heads if we needed to. So let's go ahead and make our grid and show me the steps and just kind of walk me through what you wanted to do. Good. Okay, so where are you going to put 20 plus 3 at? On the side over here? Okay. So go ahead and start through the process, and let's see what you have here. And I know that 2 times 2 is 4, and it's just a matter of multiplying.
And then you
by
add the
hundreds.
2 zeros.
Yes, all right, good. So this is 20 times 5, which is really 5 times 2 with a 0 behind it, right? We have that as 100. All right. Careful with this number here. This says 20 times 3. So let's go back and revisit this. What is 20 times 3? That's 3 20s. So we have 20, count by 20s, 20 plus.
Oh.
Use the back of your pen real quick and just erase that one piece. So what is 20 times 3? Help me out. Say it out loud for me.
60.
Okay, so let's go ahead and write our answer in there. And I know that's true because 2 times 3 is 6, and we're talking in multiples of 10. So, all right, and we have 3 times 5, which is 15. We have our grid completed. Now we have to just do the addition piece, which is nothing more than 400 plus, the next largest number is 100, plus, let's line that up. How about? Yeah, place value. 60 plus the last number, which is 15. And if you want to go ahead and draw your line and put a symbol plus, hold on to your pencil real quick. I'm just going to move that screen up so you can have some space. Okay, so what is the product of 23 times 25?
575.
575. And if we're using Mike's method, he said that we can check to verify that the answer is correct, kind of, but we can definitely use the method that he mentioned. Do you remember how he said looking at the last 2 digits that you've seen here? Those last 2 digits, what would be the final answer if I was to just multiply 3 and 5? We should end up with an answer that has a what in the ones place?
A 5.
Perfect. And I can verify that that's true because of the way that you did that. Yeah, it's very nice.
There you go. Well done, boys.
Yeah.
All right. Hey, we do have phone tutors available until 5:30. Right now, we're going to go to the phones. And Kaya, how are you this afternoon?
I'm great. How are you?
I'm wonderful myself. And you are a 7th grade student, correct?
Yes.
All right. As soon as you're ready, let's hear the math problem that you're working on.
Okay, so we have to find the simple interest earned to the nearest cent for each principal, interest rate, and time. So the interest is $1,200. The interest rate is 3.9%, and the time is 8 months.
Okay, so I'm going to need Kaya to repeat some of those numbers. I was too busy erasing with my tech over here. I apologize. Can you repeat some of that? The interest?
So the interest rate is 3.9%. The principal is $1,200, and the time is 8 months.
And the time is 8 months. Okay. So this is a simple interest problem, is that correct? I wrote it down properly?
Yes, this
Okay.
is.
So when we're talking about, this is kind of one of those where, like if I was to go to the bank and borrow some money, the principal is the amount of money that I want to borrow, correct? You understanding that?
Yes.
So what I have is $1,200 that I'm asking for, and the way that the bank is going to make this money is by saying, we're going to give you this $1,200, but you're going to have to pay that money back plus some interest, which in this case is 3.9%.
Yes.
Okay, so the first thing we'll want to do is we'll want to find out, well, if I have this, what is the interest of that amount, and we can go from there. So let's look at this a little closer and talk about what it is that we're doing. So where would you start with this problem, Kaya?
Well, so since it's simple interest earned, I'd start with the 8 months and convert it to years.
Okay. So what did you get from there? Did you come up
I
with some?
got 2/3, which is 0.6666 forever. So we can just
Right.
round that to 7.
So 0.66, and you're saying it's about 7 or 0.7.
Yes.
Okay, I'm okay with that so far. Where would you go from there?
And then I'd multiply, and then I'd convert 3.9 into a decimal.
And the conversion from a decimal, from a percent to a decimal gives you?
0.039. And then I'd multiply 1,200 times, here, let me do it on a calculator real fast.
Sure.
Times 1,200. 1,200 times 0.039 times, and then you will get $31.20.
And what does that $31.20 mean to you?
It means that in 8 months, if you put $1,200 into savings,
Well, hold on there. Before we keep going, 1,200 times 0.039 is not going to be 3120 because, like we were just doing with Calvin, we've got a 9 and a 2, so this is going to end in an 8.
Oh, yeah, you're correct.
Okay, so let's go ahead and do the math if you don't mind, since we're on the show.
8 divided by 12 equals...
So go ahead and multiply that
so-
out, Jesus, if you
Yes.
don't mind, because the 3120 is not going to be
Yeah,
it.
so Kai, did you hear what he's saying is that the answer that you gave me, 3120, is not correct. So what he's saying is that we should probably start by multiplying these out and just verifying that 1,200 times 0.039 gives us a proper answer.
I can't hear you very well.
Okay, we need to multiply 1,200 by 0.039. So I'm just going to multiply that really quickly, okay? So 9 times 0, 9 times 2 is 18. We're going to carry. And then we have 9, 10. And I'm going to have to drop this down.
I apologize.
It's okay. So we're going to go through these steps, and we're going to show everybody what we end up with here. And then we just have some zeros. So we ended up with, am I doing my math correct, Mike? Check my...
You're fine, and then just
here
move
it
it
is.
over 3 places.
3 places.
Right.
Okay, so here we are at $46.80. The last in the thousands is just a, we're gonna...
Okay, I see what I did.
Okay.
I made a mistake. Thank
So
you.
$46.80 is what we have when I multiplied the 1,200 times the interest rate of 0.039.
Okay. Cool. Thank
All right.
you.
So I'm not certain.
And we still need to do it for the 8 months, right?
Right. So that was what I was going to ask is what exactly was the question wanting you to do? Because what we did was we figured out what is 0.039 times the principal. But if we're
So-
paying that back every month,
The instructions say find the simple interest earned to the nearest cent for each principal, interest rate, and time.
Okay, so for 8 months, we're going to have to take 0.7 of that amount.
oops, I just moved something on the screen. So, I transferred it over. Okay. Walk me through, Mike, where you're at here.
So I think we had $46.80.
Yep.
And we need to figure that out for 8 months because that would be for a year.
Right.
So we're going to take 7/10 of that amount.
Okay, so what we need to do is take this $46.80 and we're going to multiply it by 0.7.
Okay.
46 point.
It would be $32.76.
And this math gave you, say it one more time.
$32.76.
And that is for 8 months.
And does that answer your question, what you needed to do there?
That does. Thank you.
All right, good.
Okay.
Well, you know what? Congratulations. You've got yourself 2 tickets to Holiday Lights at Com for that problem. And I just wanted to make sure we had all that solved right there, Jesus, because the
Yeah.
$46.80 was for the full year.
For the full year.
But
Thank
we
you.
knew that when they throw in 8 months, because on the test, obviously they're going to have $46.80 as an answer, but then that would only be for the full year. Anyway, we do have phone tutors available until 5:30. You've got a half an hour left to win Holiday Lights. We'll be back with more right after this. Today we're at Thomas Jefferson Middle School, and today we're here to Today we're at
Jefferson Middle School, and I've got Melissa with me. How are you? You ready to go?
Yeah.
All right. Read for us what we have.
5 parentheses n minus 3 parentheses equals 2n minus 6.
And if we have parentheses, what does that mean?
If we have parentheses, we have to do those first. So,
Okay. So how do you want to start with this?
So I guess we can just put 5n minus 3 and then just continue with the parentheses and then bring everything else down.
Okay. So what you're doing is you went 5, because you went 5 times n, so
Yes.
you're distributing the 5 to the n. So you get 5 times n, so 5n. And then what?
Minus 3.
Well, if we bring the 5 to the n, we also have to distribute the 5 to the,
3.
so 5 times negative 3 is
15. Negative 15.
negative 15. So we'll get rid of that 3 and put a negative 15. There you go. And you can get rid of, because we only need the one symbol in there. All right.
And then we bring everything else down.
Perfect.
Okay.
Now what would you like to do?
I guess we can continue with this. So 5 minus negative 15 would be negative 10n.
Almost, if that was an n.
Oh.
Right? So what
Oh,
we
yeah.
want to do is get all the variables together. And all the numbers on one side, the variables on the other side. So we have a 5n and a 2n.
Yes. So we
Which one is the smaller one?
2n.
So it's usually easier to get rid of that one.
Yes.
So how do we get rid of that one?
So we just subtract 2 minus 6.
Well, we're going to get rid of
Yeah.
this, which means we're going to do it on both sides. Okay? So this is a positive 2n. So in order to get rid of a positive 2n, we do the inverse, the opposite. So we'll subtract 2n. But we do it on both sides to keep everything what?
Balance.
Balanced and equal. So we'll subtract 2n here. So go ahead and go through that. Right, and that just cancels out,
Yeah.
right?
So this is just
Right.
yeah.
So now bring our equal sign down, and let's bring everything else down. So here we still have a negative 15. And what's on the other side?
6.
Negative 6, right? Just not 6, okay? So we'll get rid of that so it doesn't mess us up at all. So read what we have now.
3n negative 15 equals negative 6.
Right, so 3n minus 15 is equal to negative 6.
Yes.
Do we have all the n's on one side of the equal sign?
No, we're missing an n right here.
Well, we're not going to add an n, but we have it all on one side, right? This
Yeah.
is the only n there is now, okay? So this number we want to put over there.
Yeah.
We want to get rid of this on this side. So how do we get rid of the negative 15?
You subtract it with the positive.
So you're going to add 15 to both sides.
So we do
So
the
you can go ahead and put it right under there. So you can put a plus 15 and do that to both sides, right? To keep everything balanced like you said.
yes.
All right, so now let's draw your line and figure out what we've got.
So right here we just add 15.
That cancels out,
Yeah.
right? Negative 15 and 15 becomes 0. So what's left over here?
So the only thing left is 3n.
Okay,
So
and then put our equal sign. And what's left here? Now here you have to watch because we have negative and positive, right?
Yes.
Negative 6 and positive 15. If we combine both of those together, what will we end up with?
a positive.
A positive what?
A positive number. Oh.
Okay. But which number is it? That's the key. It will be positive.
Yeah.
How do you know it's positive?
Because if the number is positive and it's bigger than negative, it cancels to a positive
It's going to be
automatically.
positive, right?
Yes.
So it's basically 15 minus 6.
Yeah. So it'll be 14, 13, 12, 11, 10, 9.
Okay, so we have 3n is equal to 9.
Yes.
Now, because we want to solve for n, what do we need to do? Because when these two are together, that implies that they're being multiplied.
Yes.
So the opposite of multiplication is,
Division.
so what do you think we're going to divide by?
So 3 divided by 3 is 9.
Well, let's divide each by 3, right? Because whatever you do to one side, you
Yeah.
do to the other. So put a 3 under each of those.
Okay.
So what's 3 divided by 3?
1
So that cancels out.
Yeah.
All right, so we have n.
equals 2. And then an easy way to do that is just by like multiplying what equals. 3 times y equals 9.
And what is that?
3.
Go ahead and put it down. So we have n is equal to 3, but we want to check and make sure this is correct.
Yes.
All right, so let's put 3 back up here.
Okay.
All right.
So that would be.
And what we'll do is we'll just go like that so we know we're multiplying those two. All right, so let's do the parentheses first like you said. What's that?
That is 0.
Okay, and 5 times 0 is?
0.
Okay, so this whole thing equals 0.
Yeah. And then so
Bring
that.
out your equal sign.
Is
And what's
6.
2 times 3?
6. And then if that equals to -6, it equals. So we bring this down, and if 0 equals to 0.
And does 0 equal 0?
Yes.
So it checks. Perfect. So that we know that that one works. Melissa, nicely done.
And once again, a big thanks to all of the staff and students at Thomas Jefferson Middle School. We had a wonderful time while we were out there. Hey, if you'd like to do the math to come out to your school, simply give us a call. The phone numbers are at the bottom of your screen. Periodically throughout the program, give us a call and say, hey, we'd like you to come out to our school. We want to do some math in your class, and that's exactly what we'll do. We do have phone tutors here until 5:30. You've got about 20 minutes or so if you would like to win some holiday lights at COM tickets. But right now, we're going to go back out to COM and find out more about the lights and what they do with Marylou.
We are back live at Holiday Lights at COM, and I have a really, really special guest with us, Josh Barnett. He is owner of Light Tasmic. Did I say that right?
That's right.
Yay!
Yep.
And also, you are the creator of all this, correct?
So that is correct.
And
Yep.
this is your 15th year, yes?
Yes.
And you have seen a lot of change over the years.
We have. It's amazing how much everything has changed in the last 15 years. Technology, the look of the park has changed dramatically. If you haven't been out here in a long time, it looks a lot different.
Yeah, every year I come out, there's always something new going on.
That's
And
right.
that's the fun part of it. Just, hey, let's go out, let's see what's new is happening. So can we talk a little bit about the lights, the strands?
Yes,
So you've changed over.
they have. So they used to be incandescent, which looked great when you first put them up, but they use a lot of power and they fade in the sun.
And so now you're all LED.
Now we're LED and they use a lot less power and they don't fade. So the colors are just as vibrant on opening day as they're vibrant on closing day as they are on opening day.
Okay, so obviously I'm going to talk about the tree, the lights in the trees, because there's a lot of them, and this one behind us. How do you guys know how many lights that you need to use?
So what we do is we look at the height of the tree. We know we're going to do hand spacing. We used to have a block of wood that we used and we kept losing it. So we go, well, let's just use our hands. So we do hand spacing. So we kind of estimate strands based off that. The diameter of the tree, we look at that and we figure out how many we're going to need to go to the top.
So you guys just keep going.
Yeah.
Now, there was a tree way back there, and it was just absolutely beautiful. It went straight up the tree. This wraps around the tree.
Right.
The other one kind of went straight up the tree. It almost looked like an umbrella coming out.
We have two techniques. We call this wrapping and then we have throwing, where the guys basically go up to the top of the tree and then throw the lights down.
Oh, wow. Now, there was also, I noticed, wire on that one.
There is, yeah. The trees, the branches, the way they grow, they don't always grow in the perfect arch shape that we want, so we have to add some help to them.
Okay. How many lights do you have out here? Do you know that?
We have 3 million.
3 million
Yeah, people
lights.
say we have to have more than 3 million. It could be, but we say 3 million.
Wow. Okay. These are the lights you use every year?
Yes.
So you don't, but you do need to purchase?
We do add new because they do go bad after so many years, whether they've stretched out due to use. Sometimes the bulb gets pulled when a squirrel climbs the tree. So, we do have strands that go bad.
Okay, now let's talk about your designs. Behind us, this is one of your earlier designs.
Right, so this is our beaver, and I think he was here first year. So he's been here all 15 years.
Wow.
And his nose used to be a bright purple. His dam that he's building used to be a bright red. So this is lit and incandescent. Still looks good.
Yeah.
The lights still work. Still a beautiful display. But now we're transitioning over to LED. Like we talked about with the strand lights, they don't fade and they're much more vibrant and they use less power.
So is that something maybe next year he might be
When
switching?
you come next year, he probably will be LED.
Okay, so let's go from there to what is
Okay,
new, which
so-
is absolutely beautiful
Right,
over here.
over here's our peacock. So this one is LED rope light. And then the feathers are RGB lights. That's how we get the colors and they change and do different patterns.
Now, for all of that, is that a set light to make them all twinkle?
So we buy these in strands. There's 16 foot per strand. We actually have to cut them and solder the pieces together to make the design of our feather. So what we did in our shop is we laid out how many bulbs could fit on a feather. So we basically built it to those strands.
So let's talk about a design. How do you go about a design? Do you start with sketching something out?
We start with sketching, very, very rough sketches. And then we have several artists who work for us. So we give that sketch to them and then they clean it up. And then that comes back to us and then I put it into a grid. So we have 1 foot squares on a sheet of paper, and so we kind of size it to that.
So you're doing a scale, correct?
Yes.
And so from that also, do you have to determine how many lights you're going to need for this?
For that we do. We actually will calculate roughly how many feet of lighting it's going to take to light that.
Now, is that something that is all you solder together and built the frame? Or?
Yeah, we built the frame. Now, the lights are the ones that are soldered together, wires.
Okay.
But we built the frame here at our shop.
Okay. How big, we were talking earlier about the frames. Yeah. There's a certain size with
right.
frames.
So we have to think about not only how it's going to look out here for the guests, but we have to think about storage. And so our containers will only allow something that is 8 feet tall to slide into it. So we make sure everything is broken down into 8 foot pieces.
And before we go back, let's quickly, the dinosaur back there, that obviously is something that you had to break into pieces.
Right, so that's a 3-panel frame. So in the computer, we went in and adjusted it to make sure that it would fit within those 3 panels.
Well, everything is looking beautiful, and this is like the perfect time of day to come out because everything is coming to life. And thank you so much.
Thank you.
I know you're very busy, and again, thank you for showing us around, and it's all so beautiful.
Oh, thank you for coming out.
All right, so we're going to go back to the studio.
All right, thanks for that, Marylou. Nice to have Josh out there so you can find out all of the little intricacies and secrets and things behind how all of that, like Tasmic and all of those lights are put together out there. We do have phone tutors available until 5:30. A programming note also today, December 6th, the final day for live broadcast, and then we will be back in January with more live tutoring available. Right now, we're going to go to the phones, and Wyatt, how are you this afternoon?
I'm doing good.
Nice to hear. You're a 5th grade student, right?
Yep.
All right. As soon as you're ready, let's hear the math problem that you're working on.
Okay. I have a circle the answer problem, and it is D 12/31, C 3/25, B 7/18, and A 9/21. It says circle the fraction that is not in simplest form.
All right, so here we go. So I think I've got them here. So it's 12 over 31,
Yes.
3 over 25,
Yes.
7/18,
Yes.
and 9/21.
You got it.
And you want the one that is not in simplest form. Now, before Jesus helps you about this, how about if you explain to us what you know about simplest form?
Okay. I know about simplest form. Simplest form means it cannot be lowered anymore and can not be divided by any number.
Right, other than
Okay.
1.
Yeah, sure.
Okay.
Or the numerator and denominator cannot be divided
Right.
by the same number.
So when we're talking about fractions, what we're really looking at, just like you said, they cannot be divided by a common factor. So when I multiply 2 numbers together, like let's say 9, the factors for 9 are 3 times 3. Those numbers that we're multiplying by each other, they're called factors, correct?
Yes.
So when I look at this, I'm saying to myself, what are the factors that the numerator 9 and the denominator 21 might have in common? So can you tell me what are the factors for 21?
The factors of 21 are 1,
Okay,
3,
perfect.
7,
7.
and 21.
Okay, so when we look at this, the factors are actually 2 numbers that I can multiply to get 21. And you're right, 1 times 21 and 3 times 7. I'm going to use 3 times 7 because we would agree that 3 times 7 is 21. You agree with me there, Wyatt? Do you
Can you
agree?
repeat that? I couldn't hear you.
Okay,
1 second.
so 3 times 3 are the factors for 9, yes?
Right.
3 times 7 are another factor for 21, the denominator here.
Yes.
Okay, great. Let's just practice this one more time, or a couple of these. Let's do the second problem, 3 over 25. Can you tell me what are the factors, or what 2 numbers can I multiply to get 3?
You can 1 and 3.
Perfect. 1 times 3, that's the only 2 numbers. What about 25?
1, 5,
Okay.
5, and 25.
Perfect. So those are all of the different numbers that we can multiply to get 25. Let's use the numbers other than 1 and 25, which is 5 times 5. Do you agree?
Yes.
5 times 5. So those are the factors for 25. Now, when I'm looking to simplify, what the question's asking, which one of these fractions is not in simplest form? Is that what the instructions are asking?
Yes.
Okay, so when I want to find out if I can simplify a fraction like 3 over 25, what I do is I break them into factors, and I'm just looking to see, is there any numbers they have in common? Are there any factors in common that we can divide by? So let's try one more really quickly, 7 over 18.
Okay.
What numbers would you multiply to get 7? Two numbers that I can multiply to get 7.
1 and 7.
Perfect, so the factors of 7 are 1 and 7. Now, the number 18 has a couple of different ways of multiplying it. I can multiply 1 times 18. I can multiply 6 times what?
6 times 3.
Or I can multiply 9 times?
2.
9 times 2. Now, did you hear any of those numbers that were 1 and 7?
Not except for 1.
Yeah, except for 1, right? So if I was to put like 2 times 9 or 3 times 6, none of those are in common with the numerator 1 times 7.
Right.
So I'm not going to be able to cancel out or simplify that fraction at all. So this 7/18 is in simplest form. What about 3 over 25? Look at it again. Do you see any numbers that can be simplified or canceled out?
No.
What happened there?
Let me try this
Okay.
for you.
Yeah, hit back. There we go. Thank you. So there's no factors in the numerator 1 times 3 or the denominator 5 times 5 that can be canceled, right?
Right.
So this is in simplest form. 3 over 25 is a fraction in simplest form.
Yep.
So now let's look at the first one that you started with, 9 over 21. Do you see any factors they have in common? There's 3 times 3 in the numerator and 3 times 7 in the denominator.
Yes. They're both multiples of 3.
Perfect. So we can actually divide 9 by 3, and I can divide 21 by 3. And as you get better at this, a lot of people will just cross off a 3 in the numerator denominator. Are you familiar with that method where you just scratch off the numerator denominator that they have in common?
Yes.
Okay, so my final answer does simplify. So 9 over 21 is the only fraction here that can be simplified into smaller terms or into simplest form. So I'm going to write down 9 over 21. And if you had to circle it, I believe is what your instruction said to do?
Yes.
We'll agree that 9 over 21 does simplify into 3 over 7.
Yep.
There you
So,
go. Nicely done. Congratulations on that. You've got yourself 2 tickets to Holiday Lights at Com as well. We hope you enjoy your time out there. All right, young man, time for you to get back to work. Go ahead and erase that board, and we'll go ahead and take a look at the problem that you need to work on. So here it says, Emma bought 16 packages of rolls for a party. There were 12 per package.
Okay,
So we had 16 packages, and there were 12 in each.
12 per package.
There were 8 left over.
8 left.
How many did they eat?
Ooh.
And I will give you boys 4 minutes.
Okay, so if I wanted to find out how many total rolls there were, that's the first step. 16 packages, and there's 12 per package. So do you have an idea of how we're going to start this problem? Think about this. If I only had one package, how many rolls are in that one package? Here's one package of rolls. How many are in there?
16.
There's 16 total packages, so I have
12.
6. Okay, so there's 12. So imagine there's 12 of these rolls. So that's kind of like the visual that you have. There's one roll, or one package has 12 rolls in it, okay? So now what if I made 16 of these boxes? You may not know that answer, but can you figure out a method you would use to solve that?
The box?
To solve the total amount that there are. So there's 16 of these packages, and each of those have 12 in them. So I could go 16 plus 16 plus 16 plus 16. But what's another way of doing repeated addition? Have you heard of this before? Like instead of saying 2 plus 2 plus 2 plus 2, I could just say 2 times. Have you seen? So repeated addition is the same as multiplication. Right. So if I want to find out if there's 16 packages and 12 per package, can't we just multiply these two numbers? All right, so why don't we do this off to the side? Can you multiply 16 times 12 to find out what that total is? Go ahead and show us off to the side right there. And you can use any method you're familiar with. If you want to use the partial products, you can as well. So 16 times 2, he's using the algorithm. And we'll just multiply 2 times 6, 2 times 1. And 2 times 1 plus 1 more is... Okay, so we have 2 times 1, which is 2, plus 1 more. And let's go ahead and erase that and make that a little bit better. That's a 3. Is is what we need to make sure we can see that as a 3. Okay, so go ahead and write your number 3 there, because 2 times 1 plus 1 more is 3. So now what we'll do is we'll put our placeholder, and now we're going to multiply 1 times 6. So go ahead and multiply 1 times 6 for me, which is going to go right here. What is 1 times 6?
So I just write
Yeah, just write the number 6 right here, because 1 times 6 is 6. Yeah, and then 1 times 1, we're going to multiply 1 times 1, which is going to go right next to it over here. Perfect. Now we can draw the line and just add these numbers together. So go straight down. 2 plus 0 is the placeholder, so that's just a 2. 3 plus 6 is 9, and then 1 plus 0 is just 1.
And I'm going to stop you guys right there for a moment. Okay. We're going to continue the problem in just a bit, but what we're going to do right now is we're going to head out one more time to CALM and visit with Marylou.
We are back live at Holiday Lights at CALM with Josh Barnett, the genius behind all this. Okay, so we have been talking about design, and we've talking about all the lights, and actually we're located at my favorite spot right now. This is my favorite part, because it's just like a winter wonderland to me right here. How long does it take you to set up? When do you start?
We start in September, so we're about 2.5 months to set everything up.
Now, when do you guys, how many hours a day?
At the beginning it's 8, and then towards the end it's like 12.
Because I know I'm out here all the time walking the hills and all that, and I've been seeing you guys out here working.
Right, and we're doing, I think we were 6 days a week this year, working 8s, and then we progressively go to 10s, and then we up it to 12s when it gets close.
And it started at Friday, correct? It opened Friday.
It opened Friday, yes.
And so it goes till
January 6th.
January 6th. Now, how long does it take to tear down? If you start in September...
Right, it definitely takes less time, but it still takes a month.
Yeah. So is there a certain area where you guys start at when you start setting up?
We do. We try to start in the back because September's a little early to start thinking about Christmas lights. So we try to make the impact on CALM as less as possible. So we do start in the backstage areas.
Okay. So let's keep walking over here because everything's just really pretty in this area. So what about power out here?
So over the years, when we started 15 years ago, we were on 6 very large generators. We're now down to 2 in our train yard. So the power consumption used to be around 3,000 amps. I haven't even measured it this year just because we have so many LEDs that it hardly uses anything.
And there's obviously power outlets all over, correct?
What we have, so we have main power feeds, and then we have distribution that has been brought from those power feeds out to where we need them.
Okay. Oh, look over there. I'm looking at all this stuff because as it gets darker, everything is just lighting up, and it's so much fun to see. When we first got here, you didn't see it real well because the sun was out, but now as the sun's going down, everything's coming to life. And then again, Steve, if you could come over here and join us real quick. We were talking about all of the donations and sponsors and everything. Where exactly does that go to? Who does it benefit?
So I like to say that this is an investment in CALM because every ticket, every sponsorship goes right back into CALM. So we built all our new exhibits with Holiday Lights money. The Badgers right there have a new exhibit, the Desert Bighorn Sheep, the California Coast Room, which is our indoor exhibit. All were made possible by Holiday Lights donations. So,
does it benefit anything else in our community?
Oh, absolutely. So Teen Challenge operates the concessions, and so they're our partner agency. They benefit as well, so it's a great partnership. You benefit CALM and Teen Challenge.
And again, what are the hours?
Hours are 5:30 to 9. We close the gates at 8:30, open every night but Christmas.
And what are the normal hours for CALM?
So open every day pretty much from 9 to 4.
Okay.
So other than Christmas and maybe New Year's.
Well, again, thank you so much for taking your time out and then building just this wonderful, beautiful area for us to come visit and enjoy with our families. And again, come on out here. It is open from 5:30, correct?
Yes,
to 9 o'clock till January 6th. Close Christmas. You got to come out here and see this because it's absolutely beautiful. And again, gentlemen, thank you for taking your time and showing us around. It's awesome. All right, back to you at the studio.
All right, thanks for that, Marylou. And you've got about 30 minutes or so if you need some help with some math homework, preparing for a test or something like that. And right now we've got Calvin in the middle of a problem, and it was a problem where they had a certain number of rolls, packages, and things like that.
Right.
So Calvin, kind of tell us where you're at and what you've got accomplished thus far.
So
what we did is, after we did that, we did the box, and then, so.
He was able to show us that using partial products, he was able to get the same answer. So we used the standard algorithm and the partial products method. You got the same answer. You agree we got 192?
Yeah.
So we're going to go ahead and write the total product there. Now, if we know that there's a total of 192 rolls, but they said they only had 8 left, can you think of a way to find out what would be the total number of rolls that they ate? So there was 192 rolls total, and out of all of those rolls, we had 8 left over. So what are you doing here?
Subtracting.
You're going to just take away those. And let me give you some space here. Go ahead and do that math right there. Perfect. So he's going to regroup and make that a 12. And 12 minus 8 is? All right. And then you just bring down your 8, which you see there. And the number is 184. What does 184 tell us?
It tells us that we subtract everything, and then we did. And
that's
we
how
found
many
out
rolls.
How much they ate.
Yeah, that's how many rolls they ate. That's a hungry family.
I was going to say, I was going to throw it out there. How many people do you think were eating all those rolls right there? 184 rolls. So nicely done. Come on over here, Calvin. Well done, well done. You enjoy doing all that multiplying today? All right. Well, you know what? You have a new position in life. You didn't know that, did you? You are now an ambassador for Do the Math. You know what that means? You need to let everybody know about Do the Math. Can you do that? Good. Because what we're going to do is we're going to give you a uniform. So this is your new uniform. And we'll go ahead and go to camera 3 right here. This is your uniform. You will wear this every day proudly and tell everybody about Do the Math. Maybe not every day, but a lot, okay? You know what? Speaking of uniforms, our camera operator on camera number 1, I don't know if 2 or 3 can get over there and get a snapshot of her lovely holiday. Oh, you know what? She's in the dark over there behind the camera, which is, but come on out here real quick. You know what? Come on out really quick. We'll go ahead and right up here in front. Yep, come right around. And let everybody, a lovely festive hat, but that's not the only part. Tell us a little story about that. I'll give you 10 seconds.
I got these Grinch gloves over at Universal for Grinchmas when I was in 4th grade, and I always wear them during Christmas time ever since.
All right, well, there you go. Well, thank you for sharing those with us. And I would have you pick the winner, but those are not going to work, I think, in the drawing jar right there. So, Calvin, come on over. Your final duty of the afternoon, because everybody that calls in is registered to win themselves 2 tickets to any CSUB athletics event of their choosing. So why don't you reach in there and find out who our winner is for today. Who is that?
Kaya.
Kaya, there you go.
Right,
So
Kaya won.
congratulations. You got
Congratulations.
yourself 2 tickets to any sporting event at CSUB, courtesy of CSUB Athletics. Maybe you'll see Jesus out there. We'll get him cheering and things like that. And congratulations. And have a lovely holiday season. We'll see you back on January 9th with a Happy New Year. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama-Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.